Welcome to solverfy.
Once again, welcome to a new problem. This time we're dealing with specific costs, and remember that you could have fixed costs in a business. You could have fixed costs, like for example, rent. You could also have variable costs. You could have variable costs, like say wages. Fixed costs, we can symbolize that as FC, and variable costs VC, for example. And then of course total costs, TC, becomes the sum of fixed costs and variable costs. Fixed costs, they don't change month to month, but then variable costs do change based on the number of products being sold. So you could have products costing a certain amount and being sold. On the other hand, we do also have things like revenue. So we have revenue. So total revenue, TR, is when you take a specific number of items, which we call Q. These are items, and you multiply that by the unit price, and that gives you the total revenue. Revenue being the amount of money that you get from sales. We also have marginal cost, which is simply the change in total cost of the change in number of units. So this is change in total cost versus change in number of units produced, for example. When we think about marginal cost, all we're saying is the extra cost that businesses have to deal with in producing an extra unit. So that's the extra cost that we do have. Profit is obviously going to be the difference between total revenue and total cost. That's the total profit, T standing for total. We could also have marginal profit to optimize your profits. Your marginal cost has to equal to your marginal revenue. Remember, marginal revenue is changing total revenue over change in the quantity, and then marginal cost is the change in total cost over the change in the quantities being sold. So in this particular problem, we have two questions. The first one is find the profit maximizing quantity. Find the profit maximizing quantity, and then the other one is visualize the total revenue together with the total cost on the same graph. And also visualize the marginal revenue and the marginal cost graphs. So the first thing we're going to do in this particular problem is to address the the graphical issues. Those are the things we're looking at. So the first graph that we discuss is the total revenue and total cost graph. This is total revenue. Just remember that TR is total revenue and TC is total cost graph. And that's based off of the data provided. So we're provided with a quantity of units that we're producing, and so we have to bring in specific data that reflects the quantity of units. For example, one unit has a variable cost of 20 and a fixed cost of 20, and then the total cost is 40. And besides that, we have the total revenue, which is 20, and then the marginal revenue is also 20. So remember, we do have formulas for this. This is change in total revenue of a change in quantity, and this is change in total cost of a change in quantity. And then we have fixed cost, total cost, and variable cost. So taking these two together, we get the total cost. And that's why you have, for example, for quantity, we want to say for quantity 1, for example, you get to see that the variable cost is 20, fixed cost is 20, total cost is variable cost plus fixed cost, which is 40. Total revenue is how much money you get. We actually do need, after the total cost, we need a marginal cost column. So let's change this a little bit, just a little bit. It's changing this a little bit, and we're going to be back on track. So this is variable cost, and then fixed cost, and then total cost, and then of course we have marginal cost. So fixed cost is 20, so if you add them you get, and then total cost is 40. We're not going to have any marginal costs because there's no change in total cost. Remember, if we do marginal cost, that's change in total cost of change in quantity. So at the beginning, you don't really have any change in total cost because you start with a specific quantity. So we have 0. Total revenue is 20, and marginal revenue is 20. Selling 2 items, fixed cost stays the same, so it's always going to be 20. Fixed cost stays at 20. So total cost will be 45 because you're summing up these two. Marginal cost is the change in total cost. And you can see, if you want to change the total cost in that sense, change in total cost would be 45 minus 40. 45 is when you're selling 2 units, and 40 is when you're selling 1 unit. So the change in total cost is 5, and then divide by the change in quantity. You only changed by 1 unit. So 2 minus 1, which is 1. So this is 5 over 1. This is 5. That's why we have marginal cost is 5. When it comes to total revenue, we're doubling, and the reason why we're doubling is because that's going to be the selling price. The selling price for the item, which is the revenue you get from selling one unit. Total revenue for one unit is $20. Or if you want to think of it in terms of dollars, so here we're selling 2. So at Q2, for example, if you go from the left to the right, you get to see that variable cost is 20. Variable cost is given as 25. That's given. Fixed cost is 20. So total cost is variable cost plus fixed cost, which is 25 plus 20, which is 45. We already have the marginal cost we've computed right here, which is 5. And then we have the total revenue is the price times the quantity. We have the price of the selling price P is $20. So we have 20 times the quantity 2, which is 40. That's why right here we do have 40 as your total revenue. And then your marginal revenue becomes the change in total revenue divided by the change in quantity. Change in total revenue, you're seeing the revenue when 2 items are sold minus revenue when 1 item was sold divided by 2 minus 1. Revenue when 2 items were sold is 40. When 1 item was sold is 20 over 1, so this gives us 20. And we're just going to go back and see that the marginal revenue becomes 20. So from this one, we get to see that the marginal revenue is 20. And so at each level of the way you're going to proceed in the sim light and fill up the table with the required data. And each step of the way, the computations reflect or they're subject to the formulas given, 80-20. And then, of course, when your variable cost is 80 for 4 units or for 5 units, then the fixed cost stays the same. The total cost is the sum of variable and fixed. The marginal cost would be taking the total cost from 5 units minus the total cost from 4 units, which is 30, and then dividing by 1 because you're only changing a unit by 1 item. The total revenue, you have 5 items, each at $20, so $100. And then finally, the marginal revenue, you're taking these 2 different revenues, 100 minus 80 divided by 1, so you get 20 right there. Seems like the marginal revenue never changes. That's the data we have, and looking at our graph, we can say, well, on the x-axis, we have quantity. And then on the y-axis, we have total revenue or total cost. We get to see 1 item, 2 items, 3 items, 4 items, 5 items, and then 6 items. And then on the y, we have 0, 20, 40, 60, 80, 100, and then 120. Total revenue, you can see is this column. This is the column for total revenue, and then if you graph it, you have 1 and 20, for example. You have 2 and 40. So let's just try and be as precise as possible. So you have 1 and 20, you have 2 and 40, you have 3 and 60, You have 4 and 80. You have 5 and 100, and so on and so forth. So it's pretty much a straight line where if you only sell 1 unit, you're going to have 20 right there. So this is the total revenue graph. And then for the marginal revenue, if you go through the process, marginal revenue, that's the total revenue. For the total cost, this one, 1 at 40, 2 at 45, and then 55, 3 at 55, 4 at 70, total cost, when you graph it, you're obviously going to start at 40, and it kind of crosses at somewhere right here, and then goes back and connects at 100. Something similar to that. And that becomes the total cost. So we do have 2 graphs. The top one is, this one is the total revenue, and then we have the total cost. The next issue that you have to deal with is the marginal revenue and marginal cost. Marginal revenue versus marginal cost. So in that sense, you're gonna have, we could start at 1, and then we have 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, and we have 5.5. So this is 0, 5, 10, 15, 20. It's a process, a graphing process. 25, 30, then we stop at 35. The marginal revenue, as you can recall, stays the same. If you go back, you see it's always going to be 20. This is the marginal revenue right here. It always stays at 20. So we go back and graph a straight line like that, that reflects the marginal revenue staying at 20, but then the marginal cost, it rises up a little bit. For example, you can see that at 1, it's pretty much 0, and then at 2, it becomes 5, and then at 3 we have 10, for example. At 4 we have 15, for example. At 5 we have 25, for example, something like that. 25 like that. So the graph itself, it rises up a little bit. By the time it gets to 3, and then it just bends up a little bit like that. And so we just want to make sure that's 100%. And so based off of that, the profit maximization happens at about close to 4 units, for a little bit beyond 4 units. So this is the point where profit maximization happens. I think we need to shrink this graph a little bit like that. So we're going to bring it on, bring it up, something like that. It's not 100% exact, but get the point. So this is where marginal cost or marginal revenue equals to marginal cost. That's where you want to optimize your profit. So we'll say profit maximization happens when marginal cost is the same as marginal revenue, but since you are producing whole units, profit maximization happens when Q equals to 4 units. So once again, we had an economic problem where we were given a series of items. We had one item costing $20, 2 items $25, 3 items $35, 450, 580, and each one of the items had a price of $20 to be sold. And so we built a table showing the fixed cost, which never changes. It's always $20 to produce. And then the total cost, which is the sum of the variable and fixed cost. Total revenue is the product of the price times the number of units you're selling. Price times number of units. And so if you produce one item, you're only going to get $20. If you produce 5 items, you're going to get $100. We use specific formulas to resolve for marginal cost and marginal revenue. Went ahead and graphed the total revenue and total cost graph. And then followed that, you can see this is kind of like a special location where profit is optimized because you have the maximum gap. So there is a maximum gap right here. That's usually where the profit is optimized, and that's connected to this point on the marginal revenue, marginal cost graph, and that gives us 4 items. So hope you enjoy the problem. Feel free to send any questions or comments, and have a wonderful day.